Recently, I made a game about flying on rusted bars through the atmosphere of Jupiter, and like any other self-respecting solo dev, instead of adding more content and fixing obvious problems, I decided to play with cool lighting effects instead. There are many different ways to make volumetric lights, but I chose one that doesn't require additional geometry and works well even with small local lights. Also, it's not required to see the light source for it to work, which is very important for me. So in this video I'll show how I added volumetric lighting using a Froxel based approach. Let's start from the beginning. I'll show you a simple 2D case for ease of understanding of what we need to do. So for starters, let's draw our camera. It will be represented by these two lines that are at an angle to each other because we have a perspective camera. And to calculate volumetric light, we need to somehow know the value of the density of the atmosphere in each point between these two lines. To achieve that, we need somehow store these values and calculate them. To store them, I suggest to use these grid. Basically, we will overlay it over our camera volume, camera frustum, if you will, and it looks very good already because we want to have finer grid closer to the camera, and farther away it doesn't matter so much, so we can leave it more sparse. Basically, this is what we will create, and we will calculate then values like in each square of this grid, and then for the final pass we will trace rays from the camera, from the root, and we will just sum up all squares through which ray has passed to calculate the final value. Okay, let's go to Unity and see it in 3D. Here we are in Unity. From top-down view our camera basically looks just like what I have shown you, but we are now in 3D. So on the right you can see the renderer feature, which exposes controls for grid density. Now we have 3 axes, and to visualize it I've added a debug mode that shows our grid overlaid over everything on the scene. Let's disable gizmos. Yeah, this is how it looks. Each square represents some frustum voxel that intersects geometry. I can drastically reduce resolution. It updates in real time and looks really interesting, but I figured that this default resolution is good enough. Next step is actually sample these all these squares. You can see now only lighting. Also, I'll show that this technique is very simple, and you can see all the downsides right here, because for example, this object is larger than shadow distance, and you see that it should have volumetric shadow all the way up here, but it doesn't because shadow distance is limited. Also, it falls short on the edges. Basically, it's an anti-aliasing issue because, as you can see, I have here only 160 by 90 grid, and obviously here is many more pixels than 160 by 90. And let's see the final result. I've figured that this effect is really dependent on level geometry. So for example, it works really good with a structure like this, which have many holes for light to pass through. And direct lighting, on the other hand, really breaks. Basically, it breaks all the colors in the scene, so I don't like it that much. But for point light, it really can add the atmosphere. Let's increase scattering. Yes, it also has some issue with sorting. As you can see, here's some shop UI, which draws over my volumetric lighting. But from this side, it looks really good. There are many ways to somehow mitigate these issues with jagged edges and temporal stability, because when I move you can obviously see that resolution is not that great, but for me it's just fine. You can get ready to use package right in the description, and also play my game and see how it works for you. It works actually even in web builds in Unity 6.3, so yeah, I hoped I helped someone. That's all.